Let us understand different type of loads. First one load what we normally counter in the problem is point load or concentrated load. It is something like this: 4 kilonewton is acting at some fixed point that may be 2 meter from this end. So it is a point load or a concentrated load which acts at a well defined points. The second kind of force is uniformly distributed load. In short, we say it UDL, uniformly distributed load. It is like this: W Newton per meter. For 1 meter it is W Newton. So you take any meter, let us say from this side or from here to here or from here to here. You pick up any 1 meter, the weight of the 1 meter is going to be W Newton. This can be shown like this or it can be shown like this. If it is shown from below the line or beam, it will be acting upward. If it is shown from upper side, that means it is acting downward. Now how to convert it into a concentrated force? It can be converted into concentrated force by taking it acting at the center as W into L, that is area of this rectangle. You can say W Newton per meter over the length of L, so total is WL. Where it is supposed to be acting, it is assumed to be acting at the center of the length, that is L by 2 from both the sides. Now we are required to convert it UDL into concentrated force for different problems for calculation of moments. Another kind of load what we face in normal problem is uniformly varying load, UVL. It is W Newton per meter on this end, and here it is 0 Newton per meter. So this is continuously changing over every meter. So if you pick up any of the meter, the weight is going to be different. It will depend on the corresponding area above the length. So how to convert it into concentrated? We'll take the center of this centroid of this triangle. How to take it? We'll take L by 3 from this vertical side. This is a vertical side, so we'll take L by 3 from this side and 2L by 3 from this side. It will be acting here, and its total force is going to be 1 upon 2 W into L, that is nothing but the area of the triangle. If the combination of UDL and UVL can produce this kind of trapezium kind of load, so we will take it combination of both. So we'll make one as a triangular load and another one as a UDL. So UDL is W, assume a line here. So this is a rectangular load plus triangular load. So what is the height of the triangle is W1 minus W2, that is the height. So that's why it is 1 upon 2 W1 minus W2 into L, acting at L by 3 from this side, because this is L by 3 from this side, and another one is, that is UDL, it is W2 into L, acting at L by 2. In general, we can say if there is any kind of load as y as a function of x, then we can show that it is acting at the centroid, that is at the centroid. This is the coordinate of the centroid, and that it is the total load is going to be area under the load curve. So this is how we can convert any kind of load into a concentrated load, and the mostly it is required to take the movements for determining reactions or doing different kind of calculations where we need a concentrated force but not a distributed force.